Welcome to the tutorial room. Chapter 7, Real Numbers. Section 7.7, Radicals. In this section, you'll learn about roots. Like exponents, roots are widely used and are an essential skill for working with algebraic expressions. We'll also introduce you to the Pythagorean theorem, a theorem which applies to right triangles and has a number of practical applications. History. The Greek concept of numbers included only natural numbers. They did not accept the idea of irrational numbers, zero, or even negative numbers. Even brilliant mathematicians, like Diophantus, simply discarded any solutions involving negative numbers. Although the Pythagoreans lived by the words, "Number rules the universe," Pythagoras, who is credited with the Pythagorean theorem, refused to accept that a triangle with legs of 1 yields a diagonal equal to the square root of 2, an irrational number. On a sea voyage, a Pythagorean named Hippasus argued that if theory couldn't even describe a simple triangle, it couldn't possibly describe the whole universe. Rather than amend their views and study his observation, the other Pythagoreans threw Hippasus overboard and killed him, quickly putting an end to the disagreement. Section. On the last screen, you learned about exponents, a shorthand way to show repeated multiplications. On this screen, we'll talk about the inverse operation, finding the root of a number. Finding the root of a number reverses the process of raising a number to a power. You're finding one of the equal factors of the number. To show this operation, we use the following expression: the mth root of a, where this symbol is called the radical sign. A is called the radicand. M is called the index or order. If no index is shown, treat the index as 2. This means this, the square root of a. For example, the square root of 36 equals 6, since 6 squared equals 36. Since there is no index to the left of the radical sign, we assume an index of 2. So we're finding the two equal factors of 36, that is, the square root of 36. We ask ourselves, what number squared equals 36? Since 6 squared is 36, the square root of 36 is 6. The cube root of 8 equals 2, since 2 cubed equals 8. Since the index to the left of the radical sign is 3, we're finding the three equal factors of 8, that is, the cube root of 8. We ask ourselves, what number cubed equals 8? Since 2 cubed is 8, the cube root of 8 is 2. The fourth root of 81 equals 3, since 3 raised to the power of 4 equals 81. Since the index to the left of the radical sign is 4, we are finding the four equal factors of 81, that is, the fourth root of 81. We ask ourselves, what number raised to the fourth equals 81? Since 3 to the fourth is 81, the fourth root of 81 is 3. In general, the mth root of a equals n if n raised to the power m equals a. Rules of radicals. A number of rules of radicals follow from this definition. For all the rules shown below, think of a and b as any real numbers, except for 0 in the cases noted. All of the exponents and indices m and n must be positive integers. Rule of 0. Any root of 0 always equals 0. The fifth root of 0 equals 0, since 0 times 0 times 0 times 0 times 0 equals 0. Since 0 times itself always equals 0, any root of 0 equals 0. Product rule. The root of a product equals the root of its factors. The nth root of a times b equals the nth root of a times the nth root of b. Quotient rule. The root of a quotient equals the root of the dividend divided by the root of the divisor. The square root of 36 equals the square root of 4 times the square root of 9 equals 2 times 3 equals 6. The cube root of 1/8 equals the cube root of 1 divided by the cube root of 8 equals 1 divided by 2, or 1/2. To find the cube root of 1/8, you can find the cube root of 1 over the cube root of 8. Power rule. To find the root of a radical expression raised to a power, you can either 1. Raise the radicand to the power first, then find the root, or 2. Find the root of the radicand first, then raise the result to the power. The nth root of a raised to the power of m equals the nth root of a raised to the power m. The cube root of 8 squared equals the cube root of 8 squared. The cube root of 64 equals 2 squared. 4 equals 4. A word about irrational numbers. Irrational numbers are numbers that cannot be expressed as the ratio of two integers. The decimal equivalents of irrational numbers neither repeat nor terminate, but have a series of digits which continue to infinity. Some of these numbers may be expressed as radical expressions. For example, the square root of 2 equals 1.414213, etc. The square root of 3 equals 1.7320508, and so on. The square root of 5 equals 2.2360679, etc. Since some radical expressions do not have even roots, the simplified form of a radical expression may still include a radical. Example 7.7.5. Simplify the square root of 18. The nth root of a times b equals the nth root of a times the nth root of b, the product rule. The square root of 18 equals the square root of 9 times the square root of 2. Find the square root of 9. Equals 3 times the square root of 2, the result in simplest form. The Pythagorean theorem. One of the most common applications of radicals is the Pythagorean theorem, named after the famous Greek mathematician Pythagoras, who lived around 500 BC. The Pythagorean theorem concerns the lengths of the sides of a right triangle. A right triangle is a triangle with a right angle, 90-degree angle. The side opposite of the right angle is called the hypotenuse. The other two sides of the triangle are called the legs. For the Pythagorean theorem, we label the legs as A and B, and the hypotenuse as C. The Pythagorean theorem tells us that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. We can write the formula as a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse of a right triangle. Example 7.7.6. Find the length of the hypotenuse of a right triangle with legs of 3 feet and 4 feet. A squared plus b squared equals c squared. 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. The square root of 25 equals the square root of c squared. To find c, take the square root of both sides. 5 equals c. The length of the hypotenuse is 5 feet. Here, try these practices. Excellent job. Good job, you're right. Try again. Yes, you are right.